Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning. In this video, we are going to continue discussing about solving system of linear equation by using Gauss-Jordan elimination by applying elementary row operations. Okay, this is an extension of the previous video. In this video, we are going to show two examples, right? One where for the case where we have no solution, and the other example is for when we have a system of linear equation having infinitely many solution. In the previous video, we gave one example related to a system of linear equation having a unique solution, right? So as we mentioned last time, we have three possibility. Number one, unique solution. Number two, no solution. And number three, the case of infinitely many solutions. So for this particular video, we are going to show the case of no solution, and the other case is for infinitely many solution. Now let's start with this example, that is example number one, where we have a system of linear equation having three equations: 3x minus 2y plus 2z equal to 6. That's our first equation. Equation number two, 2x minus 3y plus 4z equal to 0. Second equation, 7x minus 3y plus 2z equal to -1. That's the third equation. Okay, as we mentioned last time, we can convert from a system of linear equation into a matrix. Okay, where on the left hand side of the matrix, we just write the coefficient of the variable. That is, we have the coefficient of x, we have 3 here, and for the second equation, the coefficient of x is 2. The coefficient for x in the third equation is 7. So therefore, we have our first column going down, column 3, 2, 7, because the coefficient of x is 3, 2, and 7. Now, the same thing goes for coefficient of y. We have our second row. Okay, the second row is for coefficient of y. Coefficient for z will be our third row. And the right hand side, or what I mean is the last row, the last column, 6, 0, and -1 is the right hand side of the equation. 6, 0, and -1. Here we have 6, 0, and -1. Okay, the whole matrix is called augmented matrix. So let's use this metric, okay, and apply elementary row operation on this one until we'll fulfill all the requirement, okay, in the target. Let's see. Let's do ERO, elementary row operation, on that matrix. So this is the original matrix that we get from the system of linear equation. Okay, if we look carefully at this matrix, we see that in our first row, we don't have leading one. See, the first number in this first row, this number 3 here, okay, we need to change it into 1 as our leading one. We don't have 1 yet. We have 3. Okay, so how to do that? All right, so maybe we can divide by 3. Row number 1, divide by 3. Okay, yes, we can get our leading one in this position. But that will involve fraction. We'll have -2/3, you know. We have 2/3 also over here, and then we have 6/3 is equal to 2 if we divide by 3. But maybe we can avoid dealing with fraction if, for example, we look carefully here, we have 3 at this position. In row number 2, the first number here, we have 2. If we subtract 2 from 3, that is 3 minus 2, we get 1, right? Yeah, that will be our leading one in row number 1. Why not we just subtract? That is R1 minus R2. That is 3 minus 2. We get 1. Okay, write the answer will be write that answer in row number 1. So let's do this operation, that is R1 minus, okay, row 1 minus row 2, write the answer in row number 1. So 3 minus 2 is 1, we write 1 at this first position in row number 1. Negative 3 minus, negative 2 minus negative 3 will be 3 minus 2 equal to 1. So we have 1 there. How I get negative 2 here? Let's see. 2, right? 2 minus 4. 2 minus 4 is equal to negative 2. Therefore, I get negative 2 at this position. Now, how come this number is 6? Where this number 6 come from? We subtract 6 minus 0, right? Okay, we follow this formula. Row 1 minus row 2. So 6 minus 0. So 6 minus 0 is just 6. So write down 6 there in row number 1. Okay, in the last column, this number. So 6. So this is our new row number 1. And we are happy because this number starting with 1, that is our leading one. Okay. But if we look down or below this leading one, we have 2 and we have 7. We're supposed to have 0 at this position and also 0 at position number 7. We don't want 7 here. We don't want 2 here. We want to have 0 here and also 0 here. Now, how to do that? Yeah, this is the operation that we can do. That is negative 2 multiplied by row number 1. Okay, and then we add with row number 2. Okay, that will be our first operation. And write the answer in row number 2. Now, how to make this number 0 from 7? Okay, we want to change it to 0. How to get 0? So what we do is we multiply negative 7 multiplied by row number 1, and then we add with row number 3. Then we write the answer in row number 3. Okay, this operation in red color is the operation to make 7 become 0, and the rest of this number will change according to this formula. Alright, let's do some of it and check the answer whether we have the correct calculation here. So negative 2 here, negative 2 plus 2 is 0. We have 0. The first number in row number 2, it becomes 0. Negative 3, okay, negative 2, okay, minus 3. Okay, negative 2, negative 3 will be negative 5. So we have negative 5 as our next number. Now, negative 2 times negative 2 is 8, positive, right? And negative 2 times negative 2 is 4, sorry, 4. 4 plus 2, 4 plus 4 is equal to 8. Therefore, we have number 8 at this position. Now, how come this number negative 12? Yeah, we have negative 2 times 6, negative 12. Negative 12, okay, plus 0 will be negative 12. Alright, now let's check for row number 3, how we get all these numbers here. This is the operation. Let's follow this operation and check whether all these numbers are correct. Now we have to multiply negative 7 by row number 1, and then we add to row number 3. Yeah, negative 7 plus 7, 0. Yes, we have 0 there. Negative 7, negative 3, we have negative 10. Yeah, we have negative 10 there. How come here 16? Positive 16. Now we have negative 7 times negative 2. Okay, we have positive 14. 14 plus 2 is 16. Positive. Yes, we have 16. Now this number looks strange. How we get this number? Negative 43. Let's check it out. Negative 7 times 6. It will be negative 42, right? Now negative 42, negative 1. Yes, we have negative 43. So we already checked that what we call all the elements in row number 2, in row number 3 are all correct. Okay, if we look at this matrix now and check whether all the numbers here fulfill the requirement for our target, seems very clear that it is not yet, especially in row number 2. You see, we have negative 5. Suppose here at this position, not negative 5, but we want to have 1 there. So how to change from negative 5 to 1? Yeah, we multiply by negative 105, or divide row 2. Okay, divide row 2 by negative 5, because we want to have 1 at this position. We want to have leading 1 in row number 2. Okay, either you say R2, that is row 2 divided by negative 5, or you say negative 1 over 5 multiplied by row 2. Okay, it has the same meaning. Okay, and you get the same answer. So let's divide row 2 by negative 5. So negative 5 so negative 5 divided by negative 5, we have 1. Yes, we have 1 there, and that's what we would like to have, because that will be our leading 1. 8 divided by negative 5 become negative 8 over 5. Okay, negative 12 divided by negative 5 become positive, right? So become 12 over 5 positive. So that's what we have now so far, after dividing row number 2 by negative 5. And row number 3 is still, we have like this: 0, negative 10, 16, and negative 43. Now leading 1 for row number 2 is this number. Okay, and we would like to have below this leading 1, we would like to have 0 there. Alright, so let's copy this matrix again over here. So this is the same matrix. This matrix and this matrix are the same. And this time we would like to have negative 10 change to 0. So how to do that? Yeah, we are going to multiply row number 2 by 10. So we have 10 here, and then we add to negative 10. We have 0. Meaning we multiply row number 2 by 10, and then we add to row number 3. Okay, therefore this negative 10 will change into 0. Alright, so let's do that. 10 multiplied by row number 2 plus row number 3, and then write the answer in row number 3. Alright, so 10 times 1 is 10. 10 minus 10 is 0. Therefore, we have 0 here. Now, 10 times negative 8 over 5. So, 5 times 2 is 10. 2 times 8 is equal to negative 16. Negative 16 plus 16 is equal to 0. Therefore, we have 0 here also. Alright, now let's see the last number. Okay, 10 multiplied by 12 over 5. We have 2 times 12 is 24. 24 minus 43. Yeah, will be negative 19. Okay, therefore now our new row number 3 is 0, 0, 0, and negative 19. And this last row is very interesting, you know, because if we convert this last row here, that is row number 3, back to equation, what we have is, okay, now let's write down this. Okay, this row, write it in terms of equation. What we have 0x plus 0y plus 0z equal to negative 19. Okay, that's what that row represent. Okay, we can change it, of course, into equations. From equation, we can change it into matrix. All right. Now, from matrix, we can change it back into equation. Now, let's simplify this equation that we have. Okay, 0 times x is 0. 0 times 1 is also 0. 0 times x are all 0. So 0 plus 0 plus 0, they are all 0. So 0 equal to negative 19. You see here what this equation is telling us? Okay, this equation is telling us that 0 is equal to negative 19, which is false. This is not true at all. 0 is not equal to negative 19. Okay, and this equation is telling us that they are the same. They say, okay, this equation is telling us that 0 is equal to negative 19. We cannot accept that. So this is not true. This is false. So this is a contradiction. So we say this statement is false. False. This is a contradiction. This is a contradiction. This is not true. Now, when we have things like this, okay, where contradiction or false statement appear during our process of doing elementary row operation, actually what this is telling us is that our original system of linear equation, okay, the system of linear equation that we have, that is this one, what I mean is this one, this system of linear equation has no solution. Okay, that's the conclusion that we can make from our observation here. Therefore, all right, so let's make a conclusion. Therefore, the system of linear equation, okay, has no solution. Has no solution. What is the indicator? Yes, whenever we have a false statement or whenever we have a contradiction, that shows that the original system of linear equation has no solution. Meaning there is no value of x, no value for y, and no value for z that can satisfy all these three equations. Okay, there is no value for x, no value of y, and no value for z. Okay, when we substitute those numbers in here, it will satisfy simultaneously all these three equations. There is none. Okay, those number does not exist. Therefore, okay, this system of linear equation has no solution. Okay, finish with the case where we have no solution. Okay, whenever we have a statement like this, 0, 0, 0, and then we have a number on the right hand side, that is a contradiction. Now, let's proceed with our example number 2. Okay, this time we have a system of linear equation like this, where we have 5x minus 6y plus z equal to 4, equation number 1. We have 2x minus 3y plus z equal to 1, equation number 2. 4x minus 3y minus z equal to 5, equation number 3. Now, the same as before, we can convert from equation into augmented matrix like this. So this is our matrix here, right? Now we are going to apply elementary row operation on this matrix, and hoping that at the end we are going to have what we call a matrix that fulfill all our target. All right. So first, let's do this operation. You see here, in our first row, we have 5, negative 6, 1, and 4. Unfortunately, right, we don't have our leading one yet. Okay, instead of 1, we have 5 here. You see, we don't have 1 and we would like to have 1. We'll be very happy to have 1 over here, not 5. So the question is how to get 5. Okay, again, we can divide by 5. We can divide row number 1 by 5. Again, if we do that, it will involve fraction. Okay, we try to avoid fraction whenever possible. Because now, in this case, we can do some other operation in which we also can get 1. For example, 5 minus 4. Row number 1, we have 5. And row number 3, we have 4 over here. So 5 minus 4 is equal to 1, right? So we can use that information to get 1 in our first row. So to get 1, we subtract R3 from R1, or R1 minus R3, and then write the answer in row number 1. So if we do that, let's see what happened. So 5 minus 4 is 1, therefore we have 1 here. That's what we are looking for. Negative 6 minus negative 3. So negative 6 plus 3 become negative 3. We have negative 3 as our second number in row number 1. Now, 1 minus negative 1 becomes 1 plus 1. It's become 2 there. So we get this number correct. Now 4 minus 5. 4 minus 5 is negative 1. Therefore, we have our last number in row number 1, negative 1, because 4 minus 5, negative 1. We have negative 1 there. So that's our new row number 1. Row number 2 and row number 3 still maintain. Okay, and we want to make, when we see here, this number, we look here, below this leading one is not yet equal to 0. We have 2 here instead. We have 4 there, and we would like very much to make these numbers to 0. Change 2 to 0, change 4 to 0 also. So what operation that we can do to make this number 0 and that number 0? These are the operation that we have to follow. Okay. Now, to make this number 0, what we can do is negative 2 multiply by row number 1 and then add to row number 2. Or the operation is like this, negative 2 times row number 1 plus row number 2. Write the answer in row number 2. Okay, let's check our answer here, see whether we get 3. Alright, so negative 2 times 1 is negative 2 plus 2 is 0. We have 0 there. Negative 2 times negative 3 is 6, right? 6 minus 3, we have positive 3 over here. Now, negative 2 times 2, we have negative 4. And negative 4 plus 1 is negative 3. We have negative 3 there. Now, let's see the last number. Negative 2 times negative 1. Positive 2, right? Positive 2 plus 1. 2 plus 1 is 3. Therefore, we have 3 there. And how about for row number 3? Okay, how to get and change from 4 to 0. What operation that we can do? Yeah, we multiply row number 1, multiply by negative 4, and then we add row number 3. Alright, so let's do that. So, negative 4 times 1 is negative 4, plus 4, we have 0 there. Negative 4 times negative 3 is positive 12. Okay, 12 minus 3, we have positive 9. Negative 4 times 2, we have negative 8. Negative 8, negative 1, we have negative 9. Yeah, we have negative 9 there. Now let's check the last number in row number 3. Negative 4 times negative 1, it will be positive 4. 4 plus 5 is 9. Okay, so we already checked this matrix is correct. Okay, so now let's check again whether we already have fulfilled the target for this matrix. Seems like not yet, especially in row number 2. You see here we have 3. We're supposed to have our leading one in this position, so we can divide by 3. Okay, so we multiply 1 over 3 divide by row number 2, or we can say we divide row number 2 by 3. Okay, divide all this number by 3. Okay, then we are going to have, okay, row number 1 is still the same. We haven't changed anything. We are not going to do any operation on row number 1 in this step. So just row number 2 divide by 3. So we have 0 divided by 3 is 0. 3 divided by 3 is 1. Alright. Negative 3 divided by 3 is negative 1. And the last number 3 divided by 3 is equal to 1. Therefore, now we have our new row number 2. And row number 3 is still maintained. That is 0, 9, negative 9, and 9. Alright. Now, our next step, okay, we want to make this number 9 become 0, because this is leading number 1. Leading 1 in row number 2, as we know in our target, okay, below this leading one must be 0. So we are going to make this number 9 to be 0. So how to do that? That will be our next step. Right. So here it is. This is the same matrix that I copy one more time over here on this slide. So we have 9, negative 9, 9. Okay, as our row number 3. We want to make this number 9, 0. So what we do is we multiply negative 9, or we multiply 9 by row number 2, and then we subtract row number 3. It's become 9 minus 9 equal to 0. So this is the operation that we want to do. 9 multiplied by row number 2, and then we subtract row number 3 and write the answer in row number 3. Okay, row number 1 still maintain the same. Row number 2 also still the same. Now let's check for row number 3. Okay, multiply 9 by row number 2. So 9 here, 9 minus 9 is 0. 9 times negative 1 is equal to negative 9. Negative 9 minus negative 9, it will become negative 9 plus 9, also will be 0. 9 times 1, okay, is equal to 9. 9 minus 9 is equal to 0. So there we have it. Okay, in row number 3, now all these elements in row number 3 become 0. We have 0 here, 0, 0, and all of them 0. We have a 0 row in this matrix. All right, and the position is at the bottom of the matrix. Okay, that's perfectly correct. But now, okay, seems like we are left with only two rows, two non-zero row, the first row and the second row, and the last row is become 0 row. Wait, before we make any conclusion, we see here and check whether this matrix already fulfill all the requirement for our target. See this leading one in row number 2, above it we don't have 0 yet. We have negative 3 over here. We would like to change it, okay, to 0, this number 3. So that will be our last step. So I copy one more time this matrix and write it again over here. So we have 1, negative 3, 2, and we have 0, 1, negative 1, and 0, 0, 0, okay, in the last row. And now our target is we want to make this number, negative 3, to be 0. So what we do is row 1, okay, we add with 3 times row 2 and write down the answer in row number 1. Okay, so row number 3 is still the same, 0, 0, 0. Row number 2 also, we keep it the same. Okay, 0, 1, negative 1, 1. Now, we want to make this number become 0. So we have 1 there. So negative 3 plus 3, we have 0 there. All right. So we have 2. Okay, and we have negative 3 down here. 2 minus 3, we have negative 1. We have negative 1 there. So we have 3 over here, negative 1, okay, plus 3, we have 2. Okay, so now, if we look at this matrix now, this matrix already fulfill all the requirement in our target. Okay, now we are ready to write down the answer for this system of linear equation, right? But where is the solution? Okay, now if we look carefully here, instead of having three non-zero row, okay, we have only 2 non-zero row. Okay, we don't have any information from the last row. All right, 0 is equal to 0. That is what the last row is telling us. 0 is equal to 0. Okay, we know that, right? 0, of course, equal to 0. There is no new information there. All right, now let's convert the first equation here into equation, and also the second equation, the second row into equation. All right, now from the first row, let's write down the equation that we have from our first row. That is, we have x, we have x plus 0y, or negative minus z equal to 2. Okay, this is, let's call it equation number 1. We got it from row number 1. All right, so we didn't have this dot. All right, so x minus z equal to 2. Now from row number 2, what we have is we have y. Yeah, we have y minus z equal to 1. Okay, this is from row number 2. From row number 2, we get equation number 2. From row number 1, we get equation number 1. Now, in these two equations, you see, we have two equations only. We have two equations, but we have three unknown. We have x, we have y, we have z. Okay? The number of variable is more than the number of equations. This shows that our solution is infinitely many. So, we cannot just write any number for x, y, and z. The way to write it, you see, here in these two equations, okay, z appear in the first equation, and z also appear in the second equation. Okay, now let's write down z equal to a new variable we call t. So let let z equal to t. Okay, therefore from equation number 1, from this equation we have, okay, x minus t equal to 2, right? Substitute z equal to t here. Z equal to t. So x minus t equal to 2. Now we can solve for x. Therefore, x equal to t plus 2. X equal to t plus 2. Okay, that's the value for x. X equal to t plus 2. Z equal to t. Now we need one more solution. That is the value for y. Okay, so from here, from the second equation, we have y minus z equal to 1. So y minus z, and z is equal to t. So y minus t equal to 1. I substitute z equal to t in the second equation. So y minus t equal to 1. Therefore, now I have y equal to t plus 1, right? Yeah, so this will be the solution. That is x equal to t plus 2, z equal to t, and y equal to t plus 1. So let's write down the equation in the form of coordinate like this. So we have the value for x, and then y, and then z. So for x we have t plus 2, okay, y is t plus 1, and z is equal to t. This will be the solution of this system of linear equation. Where is it? Over here. Yeah, this system of linear equation have infinitely many solutions. Where is the solution? This one. Okay, you see we have a lot. That is infinitely many solutions. Okay, if you don't mind, give me an example of a solution. Of course, we can give. Now, let's substitute the value for t. T can be any number, you know. So, for example, let's substitute t equal to 0. All right. Let suppose that t equal to 0. So, what will be the value for x? X will be t minus 2. That is 0. Okay, plus 2. X will be equal to 2. Now, will be y will be t plus 1. That is 0 plus 1. That is equal to 1. And z will be equal to t. T is equal to 0. Okay, one solution is that x equal to 2, y equal to 1, and z equal to 0. Okay, that is an example of one of the solution. Can you give me other solution also? Of course, yes. Okay, now I can get another solution by substitute t equal to a different value. For example, t equal to 1. I will get another set of solution. Can you give me one more? Yes, I can get, and I can give you more solution. I can substitute t equal to any other number. I can get a new solution. That shows that, okay, that solution, I mean, that system of linear equation having infinitely many solutions, and the way how to write it is right in this form. That is by using or by introducing a new variable t. So the solution will be t plus 2, t plus 1, and t. This will be the solution of the system of linear equation. This one. This is the solution. All right. So we have okay. Let's complete the solution for the case where we have infinitely many solution. Okay. So the step of the solution finish up to this stage here, right? So there is one example here or exercise. You can try this. This is for the case where we have no solution. X minus y minus z equal to 1, x plus z equal to 2, and y plus 2z equal to 3. I gave you already the answer. That is, the answer is no answer, meaning no solution. All right. Now, how you do the elementary row operation, you know, please try to solve that problem. And also, I give you another example here, exercise number 2. In In this case, the solution will be infinitely many solution. Okay, this is the system of linear equation. We have three equation and three unknown. Okay, hope you try that and see how you come about writing the solution for this one. Okay, that's all for now. See you next time. Wabillahi taufiq wal hidayah. Wassalamu alaikum warahmatullahi wabarakatuh.